9, number 2, with Lynn and her brother, born on the same date, just different years. Lynn is 5 years old when her brother was 2. So 3 years older, and that's never going to change, right? Always going to be 3 years older. So when Lynn's 5, brother's 2. When she's 6, brother's a year older. When she's 15, he's going to be 12, because they're always going to have 3 years between them. And if he's 25, she's going to be 3 years older, which makes her 28. So we filled out the table. That's pretty easy to do, knowing how age and birthdays work. But the question here is this a proportional relationship? So we can check that pretty easily, and I'm going to just check it with 2 of the easier numbers that are here. All right? We always check proportionality by dividing the pairs. So for instance, if I take 6 and divide by 3, which is a pair that's right here, the relationship is I multiply this by 2 to jump over to the 6. So that should be constant throughout, but it does not work in this top pair. It doesn't work in 12 times 2 or 25 times 2 either. So we know that this is a proportional relationship? No, because there is no constant. There is no constant of proportionality. So that will be what you write there for that answer. Number 3, a student is arguing that y equals x over 9 does not show a proportional relationship between x and y because we need to always multiply by the constant to get one side to the other, not divide it. Do we agree or disagree with this? Well, we're definitely going to disagree with this, okay? Because we've seen where division is fine. And in fact, if we look at a problem that we did earlier where we multiplied 1,760 one way and then we could divide to come back, division is perfectly fine to use and to write in an equation. It's just we can write it with multiplication typically, but division is okay to use. So we're going to say I disagree because division can be represented with multiplication. We can represent, we could even represent this this example right here. This can be represented with multiplication. So y equals x divided by 9 is actually equivalent to, it's the same as just taking 1/9 and multiplying it by x. It's the same thing. It's going to give you the same answer. So we could argue that, hey, you needed to show multiplication. Well, here's a version of it being multiplied. So division can be represented with multiplication, and vice versa. Multiplication can be represented by division. So no problems there. That's why we disagree.